Hi, everyone. It's Nono here. So for those who don't know me, I'm going to briefly introduce myself. I'm humbled to see there's like 233 people right now. So this is awesome. I would like to get to know each of one of you a bit more. And, as Jose Luis and Nate have said, my presentation is sort of a segue into Nate's presentation and in an introduction into what's going to come next. Briefly to say, I just would like to say hello, everyone. I hope that we can talk more later on the QA session that we have at the end, and we can see your faces. So as I said before, thanks so much for joining. I'm Nono Martinez Alonso. I put this as a handwriting because, I have two passion projects that I have to show before I get into the machine learning stuff because they're really highly related with the things I've done in machine learning, right? So this is me doing drawings and this is me recording podcasts. Podcasting and recording videos is something that since 3 years ago I've been really passionate about, and they play an important role in my life. Again, this is me, and we're gonna see these two projects first, right? I think these two projects are a response from myself, from being so immersed into technology. And I feel it's, the typical reaction is like, wow, this guy does machine learning, but then is using a pencil or a pen to do things by hand. And this is gonna be really related to what I'm gonna show. So the first one, wanted to share with you, Getting Simple. I mentioned this at the beginning, but I will expect that many of you weren't here at the beginning. So I'll just repeat a few things. Getting Simple is a podcast about living a more productive, creative, and simple life. And, it goes about my interest in exploring lifestyle design, seeing things like, can I work remotely, or can I explore things that I'm interested in on the side of my work and do other things, right? The podcast right now has 32 episodes. So I released like number 32 yesterday. And the reason why I think is important that I point you to this is because I've actually interviewed like more than 40 people already, and some of them are here in this list. This slide represents a few founders that or co-founders of startups or programs that I've interviewed. On the left, we have Ian Keo, which is known as the father of Dynamo, but in this episode, I tried to discover a bit more about himself. Ben Fry is a co-creator of processing. So processing is a really, really big enabler where people who don't know how to code can get introduced in a really graphical way and can get started with coding. Cristobal Valenzuela, with probably, his ears are like beeping really high because we've mentioned him like 5 different times today already. And I really recommend you to listen to that episode if you want to hear his view on where machine learning tools for creators is going. And then the last one, which hasn't been released yet, is Adam Menges. So he's the co-founder of Lobe AI. As Jose Luis mentioned before, it was acquired by Microsoft. And as far as I know, they're doing really amazing things to the tool. And, I'm really excited for when the thing actually comes out. The next few ones is this one. So this one actually, because my network inside of Autodesk is something that, we have a lot of contacts inside of many people we've worked with. This is a slide of people that I've interviewed from Autodesk that are worth giving a listen to. You can see Zach Crom, Matt Jessic, which has been manager of Jose Luis, Nate, and I. Panagiotis, which is one of the most intelligent persons I've ever met, that has a really idiosyncratic view of the world. And also Kim Walmsley, that is, for me, is a role model. He's managed to craft his own lifestyle in a way that I think many of us would love to have. So just a little teaser. This is on everywhere you listen to podcasts. You can get to know a small or like a big part of myself and other people if you go here. And what I really wanted to share is that I have an episode with Jose Luis, an episode with Nate, and Jose Luis interviewed myself as well. So you can get to know all of us here, and we'll just be, this would be, think about it as an augmented Q&A session with ourselves. We later also have Andrew Witt. He's also on the podcast. So Andrew Witt will be an extended, a guest lecture later. So you can go and learn more about him there. I'm making an effort collaborating with other creatives. We're preparing like transcripts of this thing and putting things everywhere that we can and trying to edit it the best we can. So I'll just leave it there. I think it's worth, expanding if you are interested in these topics. And then the other project that I mentioned is sketch.nono.map. That just arose as a return to Handcraft that has to do a lot with the machine learning project that I did in the Harvard GSD, as Nate mentioned. And in this project, I have been sketching, I've been sketching for many years, but daily for the past year and a half. And I try to at least sketch one thing every day. So it's for me a form of visual journaling. And I've done 420 days so far. So that amounts to at least 420 drawings. That is something that, also serves as a documentary of where I've been to and what I've done and all that stuff. So each illustration just goes with a short story, and they're all online and you can see them. So this would be like one of my days, just putting my camera in front of me and doing a live sketch of it. So I don't like to do any sketches from photography. I just make a point of doing them live. It might be in a place where I'm eating or having a break, or just at home, right? And this is just something I would like to mention. There is a group called the Urban Sketchers Group that, their manifesto says like it's about sketching in place. So yeah, that's me. I think
Ricardo is saying on the chat that you're going to create your own data set of paintings and drawings for later.
yes. So that's a conversation I've been having. I actually didn't put it here, but in the suggestive drawing project I'm going to show, one of the data sets that I tried to use, not that successfully, was a set of hand sketched portraits that my mom had sketched, and a lot of hand sketched trees that she had sketched for me and helped me prepare. I haven't yet done that, but I'm, that's in the back of my mind. I'm also starting already to do some automations to process automatically all these drawings. And I would really like to release in some way my data set of drawings in a way that, maybe myself or other people can use in machine learning, because I think, I have a really consistent project, and that's what machine learning likes. There is a process where the outcome is repeatable, and I'm really eager to have conversations on that topic later. So those are live sketches that I've done by hand, and that's how we used to think. We used to sketch with pencil and paper, and we've gone from doing this, some of us still do it from time to time, from doing this with your pen or your hand to doing this with a computer, right? And we've even gone to define buildings with data. This is like maybe a BIM model that gets augmented with data. And then also not drawing lines, but adjusting sliders as parameters, right? We've also learned how to use code as an interface, or we write programs to generate designs and buildings and start to code without writing a single line of code. And we're now moving towards the future, in which we, instead of writing programs, will train machines to help us make decisions. And, for instance, a bot could learn a behavior that helps us color the sketch of a house. And, this goes in line with what somebody mentioned in the chat before, where we might have machines communicating to machines without having the need to have drawings, but, we'll see where we get to. And this presents a new paradigm. That is that, by curating your data set, the designer is the programmer. And if you choose the right set of images, you become part of the, that those images become part of the design process. And the algorithm of the process of training becomes part of the design process. So, we're trying to make a lot of abstractions over complex algorithms. And, one question that I have in previous talks and conversations is, what is an intuitive interface, right? What makes an interface intuitive, and how does that enable us to design, make, create, or do anything, right? So an example that I like to show is that when I do, I need to export maybe a slice of a presentation as a GIF. I discovered that Keynote, the analog of PowerPoint on Mac, exports a GIF of all your slides one after the other automatically, right? So they wrapped an interface that is sort of user-friendly, where you can just choose a few parameters and then you export the GIF. We can also do that, like you can see there on the left, in code. Just with one line of code, we can do the same thing. but we need to look at the manual. We need to learn how the tool works, how to use a command line tool, and you know, it has documentation for developers, but that's not something straightforward as the thing on the right, because we're familiar, we're used to seeing those sort of panels where you can just select a few options and then go. In this example, you know, what the problem I had with the interface on the right is that it's not as customizable as the one on the left. On the left, you can actually go to the fine grain and change a lot of things, but on the other one, you are limited to the abstracted features that you can get to. So intuitive is familiar, right? We many times assume that something like this that has been evolving over time, this is a Photoshop toolbar, is intuitive, but you know, it's only intuitive because it's familiar. It's something that's been with us if you've been using Photoshop for a while. If you come to the world of computers as a new user, you'll have to go here. You'll have to go to the manual and actually learn what each of those icons represent, right? So intuitive is also easy. So we find shortcuts or filters or simplified ways to do something. And, you know, I have this like clicker, right? And the one on the right just has 3 buttons. So we've simplified, we've made it easier to understand what the clicker can do because it has less features. So we've simplified and abstracted. And, you know, in that level of abstracting, there is something that we see now in the connect to machine learning, right? I've seen this statement in providers that let you do machine learning where they say, oh, you can train your model with 1 line of code. I believe them, right? That's something you can do that with maybe ML5JS or AWS SageMaker or other tools. But what's actually happening is that we're abstracting complex programs that have been already abstracted for people to be able to code with them, and then abstracted once again for people who don't know how to code, just to write 1 line and just do the whole thing. So we're being swamped with these sort of abstractions, but how much do we actually need to know about them? So about the actual algorithms, if we're running them with 1 line of code, right? The first thing is that we're limited to the parameters that we can customize, that, you know, the function that we can write has, right? And one question that I get a lot of time, I think many of you might be wondering about it, is this question, right? It's like, do you need to learn how to code? And, you know, hopefully if you don't know how to code and you don't want to learn how to code, you don't have to learn how to code and you can just use machine learning, but that's really hard. So my answer to this question is maybe, right? That is maybe, depends on whether you want to get coding or you want to just get to use what other people are doing for you. Here I use this analogy, might be better or worse, but you know, we learned when we're small to do addition, just say 1 + 1 is 2. And we learn how to do that in a calculator, right? That's the first digital device that we can use for just clicking numbers. You know, but then we see that we have the iPhone or some other smartphone that is also a digital device. So it has the same applications as the calculator, but it's malleable. So the interface is flexible, you can adjust it and you can install different apps, right? And then there is custom software, right? The part on the left with the customizable apps is that you can also go and code your own apps or download apps that other people have made for you and change the functionality, right? In architecture, there's like sort of similar level of abstraction where you can do manual design. You can just get a pen or a pencil and sketch over paper. You can do this digitally. You can go to Rhino or other modeling software and do digital design. You can do computational design if we think of an iPhone as a computer or like an Android phone where you can write your own code, create your own functions, and then install into your program. And then the other level is computational development. Is when you actually are writing the entire code, the entire functions, and sharing that with other people, installing in different devices, right? Here, you know, in design practice, you can do all of them or specialize in one. And I would expect that you don't want to specialize in hand sketching today because, you know, things are moving to digital. And, you know, you can specialize in any of them. I like this quote from Cal Newport on his book, Deep Work, where he emphasizes that, well, he emphasizes 3 things: that people who can work creatively with intelligent machines are the best at what they do and have access to capital. We have a particular career advantage in our new economy. But today we're reinforcing the part of, if you're able to work well with creative, intelligent machines, you're going to have an advantage, right? And that doesn't necessarily mean you need to write the code. Nate, Jose Luis, and myself, we don't really know how to write the code of Pix2Pix from scratch, for instance, but we know how to use it. We know how to use Runway to use it. We know how to run commands that people have written documentation for. We can use it. And the good thing is that there are people that are building tools like Low to make it super easy. So easy as drag and dropping a set of images and retraining an image classifier, right? We're not going to see that today, hopefully in future videos or some other lectures that we give, but you could retrain an algorithm without having to touch a code editor, right? We've already talked about Adam, Mike Matas, and their team, so they're developing this in-house in Microsoft. And now I'm just going to repeat a bit of what has been said today about Pix2Pix, right? Pix2Pix is an algorithm that we can teach by example. So again, I want to make here the distinction between scientists or people who actually know how to write neural networks, developers, who are people who can use the code or the papers that have been written and create actual code that works, and then end users or people who are like us or maybe like you that maybe know some coding and can use the algorithms, or maybe don't know any code and just want to get going with using the neural network. So this is the Pix2Pix paper, was the original tests that they did. This is the wrap that Christopher Hess did to port that to the web in TensorFlow and TensorFlow.js. And, and this is the data set, some images that you will feed to the network in order for it to train. When we say training, is that you have a mathematical model. So it's a bunch of mathematical operations. And by feeding these images in a way that the algorithm knows how to do, it adjusts the weights on each of those operations. Just when you say weights, think about it as parameters that are on the function that are variable, and they get adjusted accordingly to the data that is on the folder that you're feeding, right? In this case, we had to get the flowers data set, so those images from the internet, and then automate the calculation of the edges of the images and just pair the images to use that as a data set. And what I'm going to talk about now, you can see, you can imagine where the influence of this project came from. This is suggestive drawing among human and artificial intelligences. This was my master's thesis project at Harvard Graduate School of Design under the guidance of Panayotis Michalatos that I talked about before. And I explore the possibilities of machine learning for the collaboration between humans and machines when drawing. Instead of architecture and like actual building construction, I tried to detach myself a bit and look more from the point of an artist or a designer. So, we as humans sketch to represent how we understand the world. And this is something that for many years has been limited to humans. So we were the only ones who could look at something, see it, and then represent it. Because machines don't really participate in that process, but this is changing, right? David Ha, for instance, on Google, that Jose Luis showed before, built a SketchRNN, and SketchRNN in some way, in this model, it learned how to continue a few strokes or start from scratch and sketch a bird. But these are what are called algorithms of narrow AI. So narrow AI means that the machine learning algorithm only knows about a really, really, really specific thing, right? A really limited set of knowledge. If you were to try to make a house with this, the algorithm will change. It's sort of changing your hand and try to complete the house as a bird again, right? What I tried to do in this project was to build an interface. So it was an iPad app in which you will have a really simple canvas and then a set of layers that I call memory in this project to see the history of all the things that have been drawn. And on the left, you'll have humans from different devices and also bots that will interact with the drawing, sort of trying to mimic the way that a human will look at your drawing and then input some or suggest some strokes, right? And he tried to depart from the point and click paradigm, which is just basically the thing that we're used to, that we get an image in Photoshop, for instance, click black and white, and if the image is too big, you have to wait for it, and then you can keep going. So here, what we'll try to do is that we will try to draw, and at the same time, bots can be working, but you can keep drawing at the same time. And bots can see and manipulate the drawings that we're doing, right? And another thing on this project, talking about that flow, is that there are two kinds of algorithms or ways to work with algorithms. On the left, you have a really deterministic algorithm. You have a problem, you want to get out of a maze or get to the center, and you have a program that generates a solution, just a path, and then you're done. And then on the right, you have something that is more like a sculpting something, right? Like you're clicking and you're modifying the spatial structure, and you get a new state that you have to reevaluate, right? This is what I was looking for in this project, right? And then, you know, coming back at what I showed before, what is the problem with a line done by CAD, right? If you go from A to B with 2 clicks, it doesn't matter. Like 1,000 people might do the same line and nobody knows who made it, what character it has or anything, because it's a deterministic translation from A to B. It's a straight line. But in machine learning, actually, because the state-of-the-art networks work with images, actual input from a human has a lot of expression, and the continuous signal that you have where each human can do a unique line is important because it provides context of the difference of one line to the other. And neural networks are, at least now, better at interpreting and generating fuzzy signals from something like this than from what we've seen before. The project entailed building a set of bots that were just programs that will get a drawing and do something different with them. And the idea was that together they could be combined as metabots, right? This was one of the earliest prototypes that I built where, you know, you can see me with the Apple Pencil and I drew flowers, and then I'll get textures of a daisy. And as you can see, one thing that I don't know if we've mentioned it before today, but as you can see, the 2 flowers on the sides are flowers that you can imagine that could be real, but the one on the middle has actual squared petals, right? And that doesn't really exist in the real world, right? And that happens, that's possible because Pix2Pix learns from the images, but then when it generates a new image, the image is synthesized from the knowledge that the network acquired. It's not an image that the network looks for on the data set and tries to retrieve. It's something that is generated, right? That's why they're called generative neural networks. And, you know, just to show you some of the things that I did while playing with these bots, the first one was texture. So in this one, what we can see is that I not only train a model with daisies, but I also train a model with roses, with sunflowers, with dandelions, and also with dresses. So I also scraped images of dresses from the Met Museum and train a model with that. In that case, you can see that all the dresses turn out brown, and that's because the model overfitted. The model doesn't really have a way to differentiate that, you know, depending on the shape of the dress, it should have a different color because there's no correlation between those features of the data set, right? And, you know, this is just in terms of what the tool can offer you. The idea was that collaborative suggestion, which, you know, you can draw a flower and then many different bots can suggest you how to color it in different ways, right? And, you know, these ones were things that were drawn trying to use the tool as it's meant to be used, right? And what happens if we don't use the tool right? This is something that Panagiotis Pan actually loved, is the idea of thinking, what happens if you misuse the tool? You know, what happens if you're trying to draw a flower, but you select the wrong model? And what happens if you draw like abstract things or other objects? So the good idea here is that you can use the accident to your benefit and try to have the machine error lead you to some different inspiration, right? And, you know, we don't want to do that probably in architecture for building buildings, but maybe on the drafting process where we're still on the conceptual design space, maybe we want the machine to be able to suggest to us things that we haven't seen before or that we wouldn't ever imagine of sketching with our hands, right? And probably, so this is the most interesting project for architects and architects, architects and designers, right? And artists. These are trees that I sketched, right? But the textures are generating from a data set of 64 trees that were hand drawn by my mom, in the garden. And the bots just fill the shapes. So there was again some post-processing with Mathematica to extract the edges from the actual sketches that my mom sketched. But with just 64 trees, we could generate textures that look pretty similar to what you will do when you're trying to shade a tree, right? And you can see some of these other ones that are with just drawing buildings. And in those, I had a model that I also trained on sketches of buildings. But for drawing things like, I don't know, the doors or the windows or stuff, I could use other models that, maybe if you want to do red, you can use the model of the roses, right? This data set actually looks like this. Maybe it's too fast. I don't really even know if you can see the animation. But what you can see on the right is the drawing of a tree, and on the left is an automated edge that we've calculated with Mathematica. It's something that you could also automate probably in Photoshop with edge detection, processing, or any other platform, right? Or you could do it manually, which is a painful process that you probably don't want to do, but some training sets or data sets actually require it. What happens here is that this process is a lot slower, and it's a process in which the artist trains the machine by example. But this is closer to how we sketch, right? If you just grab images from the internet that are pictures, the output is not going to resemble how we do these things, right? And a good example is what Nate showed before. He was generating floor plans in Rhino and Grasshopper, and then outputting them. So we're generating drawings in the environment where we usually generate them and outputting them in a way that a neural network can get it. And, again, this is the thing that we've been talking about before. And in some way, I like to use this example because this is a drawing type that I do normally, but I would have never thought of coloring it that way, right? So the suggestion from the machine comes from its input and its behavior when you don't expect it, in a way that it might generate some inspiration for your process. And of course, there is like a backlog of drawings that you can build and you can reuse in the machine to then later train new algorithms and new networks. And another takeaway is that non-deterministic tools bring unexpected results, and these might lead to discovery and inspiration, right? You can look more, and there is like a full detailed transcript of the original talk at suggestivedrawing.com. And that has what I showed, but expanded a lot. So you can see a lot of more of the thinking process behind the project, the theory that I kind of used to develop this, and also pointers to the algorithms and some other experiments that I did. So talking about experiments, before I wrap up, I have a few things that I did. So these are the things that I do just to play my computer. Probably I shouldn't spend those many hours there, but these are things that intend to be just like exploratory. I just want to have fun, right? And I mentioned Runway before. We've talked about Cristobal. So Cristobal and his team are doing an awesome job. That, for instance, allowed me to use this model. So I don't really know if you can see that, the faces are actually moving while I move. And here, without knowing anything behind the math of the first order model that you can find in Runway, just in maybe, I don't know, half an hour or maybe a couple hours, I got the data set I have been building from hand sketches of my mom. So the one on the top right, for instance, is a sketch of Jose Luis, and the ones on the bottom left are mine. And what I did here is just by recording like a short clip with 12 frames in QuickTime with my webcam, I could input that to the first order model and translate my motion of my face into all of these portraits, right? It's sort of like using Photoshop, right? You just need to select photos and select a filter and then exporting the images. And, when you open Runway, I think Nate is going to show more about that. We've mentioned that it looks like the Spotify for machine learning. The first thing you get is that you have a store of models that you can use for free, and you can even author models and put them out there. And this is me playing with it. So this is PostNet. Jose Luis also showed some pointers before for this model. So this is me just playing on the living room and trying to try this model. This is me with doing some style transfer. And this is me using old pictures of my house to do colorization. And, again, the same thing. These models are already, at least to me, they look old, because these things are things that appear 1 or 2 years ago, and they're already startups based upon this model, right? There's like the Oldify, for instance. It's a service that you can go online and they do colorization for you on images. So yeah, it's and as Kevin Kelly says, like, it's super easy to innovate nowadays because you can just add machine learning to anything, and you create a new product. All right. So how are we doing in time? All right.
Good, right on time.
Okay, so a few more things to say. So I was working on Nate's team before at Autodesk, so I also worked on Refinery, and this was just like a 1 or 2 day experiment where I tried to get the 3D output of Refinery. So this is some of the early versions of it, and get style transfer live from Runway. So what this does is that you're just getting a raw box without any texture, and you're using a machine learning model to apply to it some texture. And the argument here was that if we had the right tools, we might in the future we might not even need things like V-Ray or Corona to do renderings. We might just have the proper machine learning models that know how to map each color on the 3D image to the right texture and the right lighting, right? And we've seen, Jose Luis have shown some of those example models before. So first of all, I wanted to thank you. I still have a few more words to say before I give it to Nate again. But you can see links of this talk. We don't know where they'll end up. But right now they're at nonodogma/MIA. So I'm adding things there as we mention it on the chat, and you guys ask questions. And that's been me, and hopefully we can keep connecting. The last thing I wanted to show, and this is a segue into what Nate is going to show us, so it's a pretty cool demo, is that we've been, when we were set with the challenge of giving a lecture here, the first thing that we say is that, okay, let's get back to old folders where we have our data sets from 2017 and Pix to Pix and things like that. Let's try to get that alive and update that to 2020, right? Like TensorFlow 1 has gone to TensorFlow 2. Things like Google Colab, if you don't know it, have appeared that didn't exist before. They have GPUs online for free. So a lot of things, right? And what we've done is create a small interactive tool that you guys can open in your browser, and Nate will show you probably how to do that, and do something like this with our own models, and maybe just if you want to train models and learn how to do that with your own models. So this is me using that online tool after we put it on Runway, and using that edges to sketch model. So edges to daisies model. What I have here is just to give you a pointer that I'm also putting resources that have to do with online tutorials on YouTube that you can go to nonodogma/YouTube. I've done a few videos so far, but I'm trying to cover some basics on TensorFlow, some things with visualizing convolutions, things of how to do things step by step, but with hands-on coding. So this is for people that want to get into machine learning coding. Some things will be more advanced, some things will be more for starters, and probably you want to go to some of Jose Luis's online lectures if you want to learn about more basics in computational design. And the videos that we made specifically for this workshop is to build the drawing app. So part 1 covers an overview on Pix to Pix that you've seen already today and suggested drawing, but that's really, really quick. And then we jump into hands-on coding of building a drawing app with Paper.js. The video, right, we see Runway, we see how to actually get writing the code for the web app and how to get that started. Paper.js is a framework in JavaScript to do just drawing, like a drawing app. It's like if you were able to code your own Photoshop with layers and like vector drawing and things like that. And the second part, we dive into actually requesting Runway predictions in the browser and displaying the Pix to Pix output. So we get back the actual Pix to Pix image on the browser and display it there, right? What that entails, I don't know, is vocabulary like base64 encoding and like making AJAX requests and things like that. So if this sounds like really, really unfamiliar to you, maybe it's not the best idea. But if you want to just see what's behind all these things that we built, here I'm just coding. And this is just the 2 first blocks of the things that we coded for what Nate is going to show now, right? And we won't code today, but that's what those videos are for. So if you want to, you can go to that. There'll be, we'll post the links and all that stuff. And just a quick reference, so Paper.js, again, it's a JavaScript library we used for the drawing part, so we didn't have to do that. And glitch.com. So that's something that Nate, Jose Luis, and I have discovered recently. And it's an awesome platform if you want to get started with coding. There's a bunch of examples. You can create an account for free. You can collaborate with other people, and you can, start step by step looking at basic coding things, mainly for the web. All right, so that's all I had, Nate. And if you want to start, one last pointer. So again, the links will be here. So hopefully there are many there already, but you can see more. And I'll leave it to you, Nate. So when you're ready, you can share screen and we can see the demo. If you enjoyed this video, I'd like to invite you to take a look at my learning playlist that you can find under my YouTube channel. This is a playlist that I call Design Automation and Machine Intelligence for Artists and Designers, where you can find other videos that have to do with machine learning, automation, and design. Thanks so much for watching. I'll see you next time.